Hey everybody, it's Mr. Han here. Here are our notes on graphing lines using y equals mx plus b. And that also is known as slope-intercept form. So we've talked about y equals mx plus b, y equals mx plus b. And so you're going to be graphing y equals mx plus b. Now this is from chapter 4, but the only difference is that you're going to get slope that's a fraction. So if you can remember, okay, how to find what slope is, right? Slope is the change in y over change in x, or rise over run. You're going to be able to graph these, all right? The only difference between this and the last set of notes is that you need to graph with the y-intercept. And we can figure that out. So what is slope-intercept form? Slope-intercept form is y equals, hopefully you remember, I just said it, mx plus b. And so m is our slope, and b is our y-intercept. Okay? And slope can also be rise over run, so change in y over change in x, and that's also known as rise over run. Okay? How much is it changing up and down, and how much is it changing left and right? Okay? So what is slope-intercept form? Y equals mx plus b. We need to know what m is, slope, and what b is our y-intercept. Alright? So let's go ahead and look at this first example. We're going to go ahead and graph it on here. Before we start graphing, we need to scale this. Okay, and I'm going to look at all the graphs. I'm going to scale this by 1. So I'm going to go ahead and do that right now. 1, 2, 3, 4, 5, 6, 7. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, 7, 1. Go ahead and scale the y-axis. Negatives. And the reason why I'm not counting out loud is because I noticed that as I combine my sound, my videos, it starts getting off. So I don't want to be saying the wrong number as the video says that I'm putting in a different number. So we'll go ahead and label my x and y axis. And lucky for me, I'm on Notability. So I'm going to go ahead and copy this, duplicate it. Go ahead and use it again right here. Use it again right here. Oops, I think, nope, I did not move it. Use it again right here. The only problem is it's overlapping, so I'm going to have to go ahead and clean this up over here, which is fine. Not going to have the 11s. Just going to mark Y. Okay. So now I'm pretty much set. Oh, I gotta do one more. Duplicate. And set that one up. Voila. Alright. So, go ahead and we're going to graph this first one. Okay. We're going to graph this first equation over here. So I'm going to go ahead and copy the equation y equals 3x plus 2. This shouldn't be too difficult. We know that our y-intercept, our b is 2, and our m is 3. So I'm going to go ahead and start my line at 2, 0, 2. Remember, we always start our line on the y-axis, and that's also why it's called a y-intercept. It's going to be the point where the line crosses the y-axis, so it's going to cross right here at 0, 2. Okay, I'm happy about that. I'm going to go ahead and draw my growth triangle, or also known as my slope triangle. And here, notice that 3 is the same thing as 3 over 1. So my rise is 3, and my run is 2. So check it out. I'm going to run over 1 and go up by 3. Rise 3. So here's my first point. Go over 1, run 1, and rise 3. Run over 1, rise 3. Now if I go to the left, I have to go down 3. Oops, didn't work for me. To go down 3, and then if I want to go to the left, that's fine. But I cannot go to the right if I go down 3. Okay, and now I could draw my line. I'm going to go ahead and extend my arrows and write my equation y equals 3x plus 2. And I'm done. Now, that was from chapter 4, okay? So it's a quick review. The next couple ones, our slope is going to be a fraction. So m is going to be a fraction. And hopefully you noticed that I made m a fraction. 3 is the same thing as 3 over 1. So m was rise over run still, okay? So earlier we've been using whole numbers. The concept is still the same, okay? So here, we have another equation, and our m is 1 over 4, and our b equals -3. Now we have to remember m is change in y over change in x, which means rise over run. How much is it changing going up and down? How much does it rise? And then run, how much does it change into x? Okay? So it's going to tell us that it's going up 1, and it's going to go over 4. But we start our line at our y-intercept, 0, -3. So I'm going to go ahead and find 0, -3. I'm going to go rise 1, run 4. So I'm going to go ahead and run first, run, rise. Okay? And so here's something that's a little bit confusing, so I need you guys to be really focused right now. Okay? If I go up 1, right, or if I run over 4, I go up 1. But if I go run over left 4, I have to go down 1. Okay, and you're going to notice that it's going to keep the rise over run concept. Because look, this distance right here, oops, here I'll do this in orange, sure, why not? If I duplicate this, check it out. Rise and run did not change, okay? So as long as you are keeping the pattern the same, this will work. And I could go ahead and draw my line. Make sure I go through all of the points involved, so I gotta be careful here. Make sure I go through all of the points. And then I'm going to change that to purple like I usually do. Draw my arrows. And this is y equals 1/4 x minus 3. Okay, so here we have our slope, and our key thing is to remember rise over run. All right, next one. M equals change in y over change in x, which is rise over run. So it's telling us that it's going to change -5 over 3. Okay, so it's going to go down 5, but over 3. Over meaning run on the x-axis. And our b here is 2. So we have 0, 2. Let's go ahead and start our line there. 0, 2. And our slope, okay, is change in y over change in x. It's going to go down 5, but run 3. Down 5, but run 3. 1, 2, 3. So I have a point here, point here. I'm going to extend my line. Oops. Now I'll use purple. There we go. And here my equation is y equals negative 5 over 3x plus 2. And I'm done. Alright, so if we know our m and our b, we can still graph this. The only difference is that it's going over more than 1, right? It's going over 3. Alright, our last one here. This is another reminder. We talked about this when we talked about reflections. Okay, so if y equals 4, this is still here. This is where I can come up with the table. Give me a value where y is 4. Right, we could say 0, 4, 1, 4, negative 1, 4, 3, 4. And you could come up with a million numbers, right? Negative 204, but I'm not going to be able to graph that. Negative 2, 4. Let's go negative 7, 4. Okay? And so I could graph this. Negative 7, 4 is right here. 0, 4 is right here. 1, 4 is right here. 2, 4 is right here. 3, 4 is right here. Negative 2, 4 is right here, and here I have a line where y equals 4. This is y equals 4. X equals negative 2, so I'm going to come up with an x and y table where x equals negative 2. So negative 2, 0, negative 2, 5, negative 2, negative 2, 6, negative 2, negative 6, negative 2, negative 8. And let's go ahead and plot those points. Negative 2, 0, negative 2, 5, negative 2, 6, negative 2, negative 6, negative 2, negative 8. And here I have a straight line that goes up and down. Oops, up and down. Just going to do that first. Fix that line. And here the pink equation is x equals negative 2. Alright, so here are your notes on how to graph using y equals mx plus b. And so we're connecting y equals mx plus b, and now m is slope, which is the same thing as rise over run, which we've been talking about. Alright, if you have any questions, please make sure you ask, and good luck.